We're also going to be going through E3 wireworks for leveraging those tools, the Rockwell tools, and being able to quickly do some electrical schematics and panel layout. So we're going to fit that all within the next hour, so it's ideally, anyhow. It's going to be a little bit tight, but hopefully we get a good chance to look at some of these different tools and how they work together. We'll summarize with a little bit on the companies, Javelin and Gary, and then we'll take it from there. So again, thanks very much for attending, and hopefully this is the material that we put together is of interest to you. So before we get started with the technical side, I thought we'd just quickly introduce ourselves. So myself, I'm Eric Van Essen. I'm a product manager here at Javelin Technologies, and I work quite closely with Sanu Warriors, who's sitting next to me. And together we've been heading up the electrical side of Javelin Technologies and focusing on how to do this schematic and panel and wiring side more effectively. And then we have a crew that's joining us as guests from Gary Electric as well.
Yes, this is Gary McKenzie. I run our process group at Gary Electric. We're in charge of a lot of control system design and any turnkey applications that we're working on with our partners. Joining us from Gary is Paul Stewart, who's a process control specialist and electrical control designer. And we also have Steve Morgan, who's our motion control product manager and motion specialist.
Perfect. And we all share one goal in common. It's all about building better Rockwell systems. And that's the theme of the webinar today. So coming from different angles, it's about helping you guys work with the right tools and get the jobs done. Throughout the webinar, we use a motion analyzing tool. And then using it with Rockwell Motion in order to select and calculate the required torques and actuation, so you can select the right motors and actuators. And then one of my favorite things about that is seeing all the different solutions of Rockwell that are a good fit to solve whatever motion that you're trying to solve or you're trying to build requirements for. And you're able to compare the systems as well. As far as probably my favorite is being able to compare by cost. I think we're going to highlight today, so you can pick what the most affordable solution, but making sure it can satisfy your requirements.
After that, the other tool that we're going to look at, we're going to take some output from the motion analyzer, and we're going to bring that into a software tool that Rockwell offers called ProposalWorks. I'll just highlight both the ProposalWorks and the motion analyzer are free tools available for a download from the Rockwell website or upon request from a local distributor. But what ProposalWorks is going to do is we're going to take the motion analyzer output and we're going to leverage that. So we're going to actually bring that in and be able to start comparing costs of systems and also be able to browse and add components, other Rockwell components that are going to be required to build the electrical system. So push buttons, disconnects, PLC components. Compare pricing and features. We'll be able to roll up the whole cost of the system. We'll be able to do intelligent component selection. So what we mean by that is, as there's a whole array of options when you're trying to choose disconnects or push buttons or whatever components there are. The tool actually allows you to narrow in and eliminates mistakes when you're building those catalog numbers. It also has quick access to associated documentation. So technical data sheets, manuals, wiring diagrams are all available right from a click of the button on the tool. And then ultimately we're going to be able to take the output from ProposalWorks and hand that into the E3 package to continue designing and building the system.
Great. And then from there, we're going to have a presentation on leveraging that bill of materials and quickly populating a design where you can create schematics, panel layouts. And E3 has a lot of other benefits, of course, with adding some modularity to your design, potentially design automation, and even outputting some really intelligent documentation, including PDFs with hyperlinks that can incorporate content as well.
Typically requires the ability of working with several engineering disciplines. Typically, I'll work with mechanical engineers, control engineers, the programmers, sometimes the computer side of things. What Rockwell did to enhance all this is to have motion control expand within the control design and the mechanical design, which are the two main areas that I work with. To do this, we've used, they developed a software tool called Motion Analyzer. It's used to optimize, assimilate, analyze, and select appropriate products to do your motion control. Rockwell went a little bit further a few years back in trying to integrate this into a CAD type software package, and SolidWorks made the best sense to do for all this. So within SolidWorks, the mechanical engineer would design the machine. There's a lot of really neat design attributes within SolidWorks that can then link all the critical sizing information that a product specialist myself would require in order to bring it into Motion Analyzer and come up with a working solution. So what I've got here is a sample of a turntable. What we have is some type of indexing ring. We have a single axis with a 1-to-1 belt and a gearbox. The first thing I'm going to do is run a motion study. To best simulate this, we want to make sure that we're set to motion endless. All right. We want to then define gravity. In this case, it's going to be in the Y direction. We're going to assign a motor that we can actually start rotating. And since the motor is attached to pulley number 2, we will expand here and pick axis number 2. All right, so now we've assigned a motor. Next, we want to run some plots. We're going to look at velocity. We'll run angular velocity as one of the plots. It will be in the X component, and it will be in the rotary motor that we assigned. We're going to run a second plot. In this case, I want to look at forces, and I want to look at motor torque. Also on the X component, it will also be assigned to motor number 2. All right. What we want to then look at, the motion analyzer. So what we're going to do is we're going to allow SolidWorks to do all the heavy-duty calculations of inertia, the effects of the velocity, angular velocity, and the effects of the motor torque. In the past, I would have to spend maybe about an hour or so to get all this mechanical information and plug it into the motion analyzer. So this is really saving the person that's going to be sizing up a servo system. This really saves a lot of time, because the mechanical guy is going to be designing the machine, and we can just import all this into the motion analyzer. What I've got going here is just a simple trapezoidal, 3 trapezoidal moves with 1 large move back. Okay, total cycle time is just over 5 seconds. Normally, this is where I would go in and I'd ask the engineer all the specifics about the mechanical design. How much does it weigh? How big is it? But again, I don't have to touch that because it's already done in motion or in the SolidWorks. The radio button up here will link the 2 softwares together. Now there's several steps. I'm just going to go quickly through the steps because I'm limited on time. So once I launch this link, it will pick up on the SolidWorks drawing that I have open. And I'm going to assign it to motion study number 1. Number of axes I want to deal with, the actual physical axis I'm going to run. Now, if I can move this over a bit. So at this point now, I'm ready to actually have the motion analyzer communicate to the SolidWorks, and you can actually see the ring start moving. So now this is where I'm taking those plots and I'm going to be analyzing the effects of torque and angular velocity. A couple of cool things you can do. I'm not going to do it while it's running, but if I click on the object here, I can actually change the materials, which will change the effects of inertia. And I can also bring that into the motion analyzer to see how it would affect, if maybe rather than steel, I go aluminum or something like that. Okay. Once it's finished its analyzing, it's going to bring in those 2 plots. So you can see here. I'll apply it. Okay. I'll come back to my sizing software here. If you remember before, I had nice clean trapezoidal type moves. You can see that I've got some curves going on here, so that tells me that I was successful in bringing all that data over from SolidWorks. Okay. I then simply come to the selection tab. I can minimize what I want to look at. Otherwise, if I selected everything under the sun, I might have 1,000 different options to look at. So the end results is I have 13 different solutions I can look at. Now this is one of the unique things about the motion analyzer. Cost is usually the big factor when you're selecting motion solution. So if I hit the cost factor here, I can organize by the least cost solution, which is basically looking at the servo motor, the drive, and the gearbox. However, when I look at the selections here, my first two are yellowed out, which tells me there could be something going on. Could be, in this case, I got average power, possible issues. If I scroll across, I can see peak velocity could be an issue. So this may not be the best solution to look at. Green is always good, so we're going to look at the first solution here by double-clicking on it. So what you'll see here is that based on my cycle profiles, based on all that information that I brought over from SolidWorks, it's plotted all my necessary torques. Peak torques are the red dots. The green dot is the average between all of the cycle profiles. The green line here represents the average torque of the motor, and the red line is the peak of the motor based on the drive and the motor that I've selected, as well as the gearbox. Okay. Now, depending on certain loads, you may have some regen energy to worry about. So up in here, we can take a look to see if there is going to be any regen, and then take steps to take care of it. In this case, I have none. So at this point, I've satisfied the mechanical engineer's requirement to make sure he's got a good working solution. There's a lot of other tools within Motion Analyzer that we can use to simulate tuning and stuff like that. Again, I'm time restricted, so I'm not going to go into that. At this point, we're now going to pass it off to the control engineer. So we're going to start developing a bill of material. So this is basically, you can select things like fuses, line filters, cabling systems, all right? I'm just going to switch to a finished sample. Okay. So what I've done, I've gone through and I've said, okay, give me an AC filter, give me some circuit breakers, give me some fuses. I then come over to view my BOM. And so this is everything that I brought over that I've selected as size of cables, motor, drive, fusing, all that wonderful stuff. I can add things like software. Maybe I've got in this case, I'm using our new Kinetic 6500 SIP motion servo drive. So it allows me to select the appropriate new Ethernet card to go with that. I then come to a finished bill of material, at which point I can send it to Excel to finish off the rest of the hardware. And at this point, I'm going to pass it over to Paul Stewart, and he'll take it from there.
Sounds great. That was definitely pretty interesting. So right from SolidWorks over to motion analyzing, creating a BOM, and then we'll pass over the presentation to Paul, and you're going to go through some of the proposal builder, I believe, to continue working on that same system.
Yeah, thanks, Steve. What we've got now is in front of us is the output from the motion analyzer, and all the components that Steve has gone through and selected. And it's generated a bill of material and exported into an Excel spreadsheet. So as you can see, we've got the list of all the components that Steve has gone through and selected. From here, we're going to take the motion system and parts and bring it into a tool. Again, like Gary mentioned at the beginning, this is a free Rockwell tool that is available on the web. And we're going to take those components and bring them into ProposalWorks. And we can work from those components. So all we have to do is select the components, do a copy, and paste them into ProposalWorks. What ProposalWorks is a tool that Rockwell's developed to help with the ease of component selection. It takes a lot of the flipping through multiple catalogs, and it has a complete Rockwell library within ProposalWorks. So you can select components from, as you can see, the motion control components came up. You can select push buttons, contactors, right down to the PLC. What I want to make sure everybody's aware of with the ProposalWorks is it's a software tool that's used to select on the component level. You can select PLCs, which I will do a little bit later on, but it's not really an engineering tool. We do have free tools from Rockwell that are used in PLC design for control system design. So you'll see that when we get into selecting PLCs. So as you can see, I brought in the components from the motion output of the motion analyzer, and it starts to build your, you can start working from this BOM and adding components. What you'll see is it'll give you a description. You'll notice it starts to bring in, it's defaulted to list pricing. You can alter that to reflect your pricing levels. So it'll bring in the price of the components, and you'll notice down in the bottom corner, it'll start to total up your complete bill of material. One of the really nice features on ProposalWorks is if you look up into the right-hand corner, you'll notice that you'll have some of the technical specs of the components. So if you look down the list, every component that is brought in, it will give you a lot of technical information. You can look at 3D drawings to get an idea on size of components. You'll get some short circuit current ratings of certain devices required. And there'll be links depending on the device and the information available. It'll even bring you to some installation instructions and wiring diagrams for the different devices. So a lot of information, not just part number and stuff, is brought in from ProposalWorks. So what we can do is we've got now just our motion system components, and we need to build on that. The system is going to consist of going into a panel with a lot of other devices, push buttons, contactors. So what we're going to do is we're just going to add some components into the system to start finishing off the control system. So I can browse the Rockwell library. I can either browse by keyword or catalog number. If you're unfamiliar with the catalog number you're looking for, you can just start to type in, I'm going to in this case just look at bringing in a push button. And it will start to narrow it down and give you the options for push buttons. So I'm going to choose a push button, just a simple push button. A lot of different options out there on push buttons, lens color, voltages, types. So what ProposalWorks will do is it'll step you through a selection process, and it'll only give you options that are viable for that device, which helps to eliminate a lot of mistakes with selecting components. So I can go through and just anywhere there's red, and you can see it starts to build the part number up here. I start to fill in the information that I'm looking for. Extended head, here's where I would pick the lens color, and I can do separate component selection. So I'm going to choose a plastic latch. I'm going to bring in an LED. What voltage is that LED? And what color? So when I've done that, I can accept and build that part number. So it'll start to add that part number to the BOM. So you'll see, and then the cost as well will come in. Now when you start to select different components, we can also look at adding some PLC components to this bill of material. So if you start to type in control logics, you can start to select your PLC components. Again, this is not an engineering tool that's going to look at control system design. It's more for component selection of PLCs. So it'll give you all the options available, and I can start to select my processor. I can go through and select my different chassis sizes that I want. You'll notice there'll be I/O modules, all the I/O modules that are available. I could start to build my components. Here I'll add a chassis, power supplies, any communication modules that you'd like as well. And if you accept that, once you're done, you'll notice it brings it in to ProposalWorks as the control logic subsystem. And it'll start to tally up your pricing of your complete control system. Again, if you look in the corner, you'll start noticing more and more technical information is available for the devices. You'll notice, like for an example, on an I/O card, it'll bring in a quick wiring diagram for the I/O card. So once you've got all your components selected for your system, what you can do from there is you can go and export that to Excel. And you can decide what you would like to export. Could be just the pricing, quantity, description. You choose and you click generate. So if I choose just quantity, description, and I just want to see the cost of each, I can generate, and it will export that into Excel. So now I've got all the components that Steve had brought in, and then all the components that I have added as part of my bill of material.
That's great. So then from there, again, bill of materials transfer, what we would do is pass that bill of materials over to the electrical side, where Sanu next to me is going to finish off some of the electrical work.
Thank you, Eric. Let's get started with the next step in the process, the electrical design. E3 lets you get a jump start into it You can simply add these components, copy them from the bill of materials that Paul produced, and update your device, your electrical design, by simply clicking a button. And all the devices are updated, automatically given the device tags, and all this data has been taken care of for you. And you can go ahead and start the design. The window here on the left of your screen is the device tree. You can see a nice preview of it in the preview window down here. Sheets are very easily managed in E3, all part of one project, and you can easily turn them on and off using these checkboxes. Turning them on, this is a panel sheet that I'm going to do some panel work on, and a few sheets for schematics. Let's start our design by pulling the input card, the PLC input card that Paul added to the bill of materials. You can simply do that by dragging and dropping it into your design. Next, I usually connect it to a terminal block, and I am sure that you agree that the next thing to do is to connect to a terminal block. And you can find all your devices in E3 in this library window on the right side of the screen. It's a very extensive library, but there's a great feature, and I really love using it, is filters. You can filter down to the devices, down to the ones that you regularly use. I really like doing that because it keeps my drawings consistent and saves me a bunch of money for purchasing costs. What I'm going to do is pull in a subcircuit here. Subcircuits are a combination of devices and connect lines that you can save in your design if you use them very often. In this case, I do use them very often to connect to my PLCs, and I've saved them in my design. Making connections is very easy in E3 as well. You can make quick and fast connections using this connect toolbar, and connect all these by just box selecting and connecting. You can, while you're connecting these and adding devices, an enormous amount of data is being collected automatically by E3 wireworks and displayed for you in connection tables, where all the connections that you're making are documented your device table, which is an online bill of materials for you, keeping a tab of all the devices that are in your design.
So that can just save an enormous amount of time. So being able to, like I imagine that there's a lot of designers that are out there keeping track of those tables manually if they don't have a tool like E3 to do that for them.
Absolutely. These things are right now, like I used to do them manually before I was introduced to E3 myself. Let's go ahead and add some more things to the design. Let's add some proximity sensors. You can again drag and drop them very easily from the library, or you can just, if you want, you can just copy paste these into your design, and E3 takes care of the device tags itself so that there are no duplicates.
I think it can even rename the device tags based on sheet location as well. Is that right, Sanu?
Absolutely. And as you notice that we are on sheet 1 right here and on line 2, and it's already done that for you. If that is the standard you follow, if that is not the standard you follow, you can make it appear as the standard that you follow.
That's great. Yeah, that can save a lot of time.
If you are connecting devices that are not on the same sheet or remote locations, you can connect them, and E3 keeps track of all the information that is required so that you can keep them all associated. You can again box select and connect them, and you'll notice that E3 pulls up the signal information from the different sheets and brings it back to here, propagating it through to your device. Keeping all your signals associated is an important thing, and it takes a lot of time right now if you are not using an intelligent system like E3 wireworks. It, as I mentioned, it keeps references. You can just jump to your references, a very easy menu to use. And here we have it from a different sheet where I've done some higher level system design, which E3 is great at doing as well. I did mention subcircuits earlier. I'm going to drag in another subcircuit. Subcircuits are very powerful, as I mentioned. You can drag in entire sheets or entire designs, and they can be entire projects as well, if that is what you require. And they can be made configurable using options and variants. So if you wanted to add another rung of motor control to your design, you can simply do that by checking this checkbox, and here you have another rung of motor control added to your design. Or if you wanted 3, there you have 3, or you can configure it to be as many as you want, or whatever you need to.
So that's where I think we've seen a lot of clients headed that direction. So we have a lot of clients who are trying to modularize their design work so that they can really reap the benefits of reuse and saving a lot of time and not doing these schematics manually.
Exactly, Eric. When you are doing modular design, you are saving a bunch of time so that you don't have to do the same design work again and again, as well as you can make new systems because now it is modular, not interconnected through some design that you have to make again and again. E3 is great at cabling as well. You can add cables by simply selecting them from your the library and adding them with just one swipe of your mouse. If you wanted to add, notice that it has already assigned the cables to your connections.
So each individual core of those cables got assigned to the connections, just going through.
Absolutely, it is a 3-core cable, and there are 3 connect lines there, and all the 3 cores are now connected appropriately. Gotcha. You can add wires as well to your design by selecting which wire type you want to add and add them directly by just a swipe, and it is automatically given them the core numbers and connected the right gauge of wires. If you, let's go ahead and add a few more. If you notice that it's not letting me add any wires to this connection here, because if you notice on the left side of your left bottom of your window, the cross section is not under limits. What that means is E3 is keeping online check of the design rules that you need so that you can maintain your quality. In this case, the cross-section was not within the limits of the devices that you're trying to connect. I can easily just change this cross-section of the wire and connect them again with a single swipe, and it's now lets you connect it, maintaining your quality. Let's move on to some panel work here. Panel work is very easy to do in E3. Again, it is all your devices that are to be placed in the panel are managed in this panel unplaced tab, and once you place them, they move to a panel place tab. It is more like a to-do list for panel placement or panel design. You can place these devices by selecting the entire section or one by one and drag them into your device. E3 highlights the places where you can place the DIN rails that you can place them on, and if you try to place them on DIN rails that do not or cannot accommodate these devices, it will give you an error. Again, keeping your design quality up. When it's the right rail, it will snap on easily. Let's place some PLCs, a switch, and as I'm placing more devices, you'll notice that there are these dotted lines showing up between devices, showing you the connections between them from the schematic. This is the logic being carried over from the schematics.
So you just place that entire terminal strip in one click there?
Absolutely.
Wow.
Yeah, it does take it used to take me a lot of time, and I'm sure a lot of users out there are doing a lot of work making panels, and with this logic that is being carried over, you can optimize where you place these, so you can optimize the space being utilized in the panel, which is at a premium all the time. Well, we have enough devices in here for now. Wiring the panel is another thing that takes quite a bit of time, and I'm sure people agree out there. In E3, you can just select the devices that you want to wire and press the button on the top of toolbar here for panel auto connect, and E3 will go ahead and connect all the devices that that can be connected with this wire gauge. Again, keeping the quality up. Here you see that the PLC is not connected. I can easily change this to a different wire gauge, select it, and connect. And it's all automatically connected, routed through the right ducting, keeping the high voltage and low voltage signals separate, and also gives you a fill rate for the ducts. And currently the rule is set, for my rule is set to 70%. So if your duct gets more than 70% full, it will reroute it, and still keeping the signals separate, but it'll reroute it so that you don't end up having problem with the ducting when you're actually building the panel. Creating reports is another thing. It's a really difficult thing if you don't have intelligent systems to create paneling reports, and in E3 you can create this with a click of a button. You have one click of a button and you can create a wiring list for your panel, complete with from to information, wire numbers, wire types, color, gauge, the length, and even the ducting route that you've used. And it also gives you something that you can keep track of your wires with. It gives you total length of wires and which wires are used, especially now when the copper is so expensive. You can choose to do your 3D design, your panel design in 3D as well in E3, and this really helps when you're trying to squeeze things in tight spaces to get the space requirements, or just to see what the wires, how the wires are connected or how they're routed. It's very easy to do designs or move stuff over if you needed to, and just overall general look and feel, because I really love looking at my designs in 3D. It gives me a better idea of what's going on in the real world.
Well, I know some of our clients are even using that for sales purposes. Being able
Absolutely,
to
take a snapshot of it and putting it out there so that your customers can see what is actually there rather than just a 2D image.
Yep.
These devices in the panel, the symbols in the panel and the schematic are not separate. They are different views of the same device, and you can jump to and you can navigate to them easily from the panel to the schematic by just right-clicking and jumping to it. Or if you wanted to do that the other way around, just jump to your panel to see where this is connected or where this is placed. You can do that very easily as well. E3 keeps everything very associated and understands that this is the real world and all these devices are one and the same, just using different views. You can another big aspect of design is creating bill of materials. Steve created a bill of materials, Paul did, but when you the finished bill of materials usually comes after the design is over, and you can spend what we are doing right now, hours and hours of time trying to create bill of materials, or you can do that with a simple click of a button in E3, and you have all your bill of materials done, ready to go, all rolled up with all the information that you require or the information that you would like to have in it. You can also produce PDF documents and intelligent ones for that in E3. The PDF documents keep all your references that you have alive, and you can use them to simply click and jump to your references and track them. This is very helpful in giving intelligent drawings to your customers, or just for troubleshooting purposes, or just for a team review if that is what you need for. I think with E3 wireworks you can save a bunch of time, and working with Rockwell you can get what you need where you need to be in the shortest time possible.
That's great. Thanks so much for that overview, Sanu. And actually, thanks to everybody who did a demonstration there. So to Steve and Paul as well. I thought that was some great content today, and it's a lot that we fit in an hour there. Hopefully, it touched on some main areas that everybody in the audience can relate to. So we're actually on time. That's I was surprised, but not surprised. I know you guys did a great job preparing for that. We've been recruiting for this webinar, and there's a mix of clients from both our sides, and there's probably people out there that don't really know either one of the companies perfectly. So I thought we'd introduce just quickly about who we are and what we're all about. So Javelin Technologies, we've been a reseller of technology for about 14 years now. So we have about 50 employees. Our flagship product is of course SolidWorks, but we have branched out and offer a variety of complementary solutions and even standalone solutions when it comes to electrical design is a great example. It really works great for schematics, panel design, and integrates well with other tools that we showed today. We actually just moved into a brand new office. There's some SolidWorks models of it when we had some of our crew do some of the layout and planning of it. So in a few months we'll have an open house, and everybody's welcome to come down to that as well. So that's a quick summary of some of the work that we do.
Thanks, Eric. And yeah, for those of you who may not be familiar with Gary Electric, we're an electrical distributor, actually the largest independently owned electrical distributor in Canada. Our responsibility is predominantly in Southern Ontario, and we're the authorized Rockwell distributor for a large part of Southern Ontario. A big part of what we do is working with customers designing automation and control systems. So we kind of recognize that, hey, purchasing the components is a large part of the total cost of any automation system, but it could be anywhere from just 50% to 25% of the overall cost, a lot of that being engineering. So we're always looking for ways with our vendor partners like Rockwell, how we can assist our integrator customers on the streamlining of that design. So that's where we spend a lot of our time. We do have a lot of experience with this. Our company is 54 years in business, approximately about 300 employees, and we've actually been specializing in automation since 1982. We've had an automation division since that time, and a large part of that is control system design. There's several services that we offer, training on all aspects of control systems, be it motion, process control, software. We also like to provide some engineering services to our integrator community. Again, recognizing time constraints, trying to help our customers be cost effective when they're designing. systems. So anything that we can do to shorten that life cycle, anything from the assisting with selection of components to full turnkey design for our integrator community when they're strapped for time. So there are times that we'll take on the responsibility of designing the control system on behalf of some of our partners.